Hey, welcome to GeoSolve. In this question, we are given an isosceles triangle ABC with equal sides AB and AC. Also, line segments AD and BC are given to be equal. The apex angle of the large triangle is given to be 20 degrees. And we need to find this angle alpha. I will solve the question in 3 different ways, and if you want to try it yourself before, pause here and come back for the solutions. Now let's start with solution method 1. We know that triangle ABC is isosceles. So its base angles should be equal, and let's call them beta degrees each. If we sum up the internal angles of this triangle, we can find beta to be 80 degrees. And let's show these angles on the question. Now remember that we are given AD and BC are equal, and we need to make use of that information. So let's create this equilateral triangle with same side lengths as those line segments and connect point B and point E. Now first let's isolate triangle ABC. Then focus on this blue triangle BAE. And let's rotate and isolate this triangle also. If we study these two triangles, we can see that the bottom line segments are clearly equal. Also in both triangles, the left leg is line segment AB. And finally, in both triangles, the angle between the equal sides are 80 degrees. And from this information, we can conclude that these two triangles are congruent by side angle side rule. Therefore, all corresponding internal angles must be congruent. So let's see the 20 degree angle on our main drawing. Now focus on these blue and green triangles. These two triangles have all of their sides congruent, and that makes them congruent by side rule. Therefore, this angle should also be alpha degrees. From here, we can see that 2 alpha is equal to 20 degrees, and alpha will be 10 degrees. And that is our answer. Now let's clear the screen and start our second solution method. We know that triangle ABC is isosceles with these yellow equal sides. And we know that base angles are 80 degrees. Now let's create this equilateral triangle with a side length of these equal sides. Also connect point C and point E. Now focus on the shaded triangle ACE. We notice that this is an isosceles triangle and should have equal base angles. Since we know the apex angle as 40 degrees, we can calculate the base angles as 70 degrees each. So this small angle should be 10 degrees. Now let's focus on this shaded triangle. If we sum up the internal angles, we can find the missing angle of this triangle to be 20 degrees. Now let's focus on these two triangles. Notice that we have a common 20 degree angle in both triangles. And in both triangles, the line segments forming these angles are equal. And that means that these two triangles are congruent by side angle side rule. And from here, we see that angle alpha should be 10 degrees. And that is our answer for solution method 2. Now let's start our third solution method, which is in my opinion easier than the first two methods. First, using sine theorem, let's call line segment AD as sine alpha. Then we can call line segment BD as sine 20 units. Since we are given AD equals BC, line segment BC will also be sine alpha units. Then we can use exterior angle theorem to see that this angle is alpha plus 20 degrees. Now let's apply sine theorem on triangle DBC. And that will be sine 20 over sine 80 equals sine alpha over sine alpha plus 20. And let's write this equation in a single line as follows. Now instead of sine 20, we can write 2 times sine 10 times cosine 10. Let's leave this part as the same. And instead of sine 80, we can write cosine 10. Here cosine 10 terms will cancel. And from this step forward, alpha can again be found as 10 degrees. And that concludes our solutions for this question. If you have other solution methods, please leave a comment below and we can discuss. I'll see you on the next one.